All right. Welcome everyone to GraphQLfm once again. We had a little break there, a few weeks without GraphQLfm, but we're back with an awesome guest. First, Tony, how are you doing today?
Oh, I'm doing fine, Mark. And this is going to be a little bit confusing for me because I'm the only not Mark here. So we've got Mark with a C and Mark with a K. I feel like maybe I should change my name to like Mark with a Q or something. I don't know.
That works.
Yeah, I'm doing great.
Awesome.
Doing,
I'm pretty good.
With a C.
Oh, I see we already have our first.
Already. Be sure to use C versus K. I'm doing good. Let's introduce Mark with a K right away. We've got Mark Larah from Yelp today. How are you doing, Mark?
Yeah, I'm doing great. Thanks for having me on.
Sweet. So let's get started right away. I think the first thing I wanted to talk about is if I remember back to my times, I think back then it was Shopify, like Yelp was one of the first kind of like vocal company about like we're using GraphQL now. I remember seeing like the public API and everything. Can you talk about like how that came to be, like how Yelp decided to use GraphQL?
So the public GraphQL instance I should mention is it's owned by like a different team to the team that I work on. I think we kind of launched the GraphQL endpoint to like our third-party Fusion API 3-4 years ago, I want to say. So yeah, that's like managed by a different team. So I'm probably not best placed to give an answer on that kind of stuff. But we have some really cool blog posts announcing it, and I can probably share some links to that after the stream.
Great. What about the internal part of it? Was it kind of like before or after? Did you adopt like kind of both at the same time?
Okay, so yeah, so the internal GraphQL stuff that is something that my team worked on. So that was launched around. We started work on that around 2 years ago, I'm going to say, and that kind of came after a time of we'd just kind of finished converting over our front ends to React for a lot of big pages, and it's like this time of great transition. But we were in this space of we're a Python shop, and all of the data comes from like a bunch of different backend services in Python, and then you've got to like serialize this like big JSON blob of data, in like a script tag or something, and then pass it to your React component, and then drill it down to where it's needed. And I don't know if people were like complaining like, oh, this is so terrible, because like maybe it's not a problem that you realize that you had, but like we knew GraphQL was a thing, and I think there had been like various attempts at internal GraphQL services before, but it kind of seemed like the right time to reevaluate and really try this. And we did some internal case studies to prove like the business case, and kind of like verify that, hey, this actually like saves us time on an average ticket on the business page. So that kind of like really, drove us forward.
It's interesting that you did the third-party API first, and then the internal use case came second. Was that like a intentional, like, we'll try this out over here first and then see if it works for us, or were you like, oh, this is so compelling?
Yeah, I don't know if it was like much. I mean, we took inspiration from the like public API in terms of GraphQL is an awesome technology, and like we're familiar with it as Yelp because of that, because of that experience. But it's like a different like use case entirely. There's like no sharing of the schema. It's in a different language. It's written in Python. Yeah, I don't know if that kind of answers.
Yeah, that makes sense.
Yeah, so like what's the context here around kind of like Yelp's architecture here? Are you dealing with a monolith, or a bit more like Tony's context with like microservices and everything?
Yeah, so Yelp was started in 2004, and we have a lot of code, and it all started off in this like big monolith. And I think like other sort of companies, we still have this like big monolith, and we're trying to move. We've done a lot of great work actually recently on that, but we have like call them backend services for different entities, I guess you could say. And then we expose all that data through like these hundreds of endpoints, just random, HTTP endpoints. And our GraphQL server is an abstraction, a public abstraction over all of those endpoints.
That makes a ton of sense. That seems like definitely a common use case. So you've been using GraphQL for 2 years, you said now, so you must be like getting to like a pretty large schema. And I know one thing I really want to talk about is like how you manage that. And recently, I think I'll post it in the chat, but you wrote this amazing blog post called the Dream Query. And yeah, so I kind of want to talk about this. Can you talk about the Dream Query that you call it? Like, it's a technique you use to kind of like scope down projects and define what you want to create, basically.
Yeah, so it's solving kind of a couple problems, the Dream Query. So okay, so imagine you're on a feature team and you're implementing a new page, or you are refactoring an existing page to use GraphQL. Either way, you have like a set of data, a set of fields that you need to grab from GraphQL and display it in your components. So the idea is that you just write the query that you wish you could write if everything was magically available in the schema. And you can start off by just kind of like writing it and drafting it in a Google Doc. And then people can be like, oh, this field actually already exists, but it's called something else. Cool, and then you tweak it. And maybe some stuff just like doesn't exist in the schema, and that's fine too. It gives you a sense of like, okay, well, we're going to need to create like 5 resolvers, so that's going to equal this much time, for someone to implement. But then the really cool thing is once you have this query, this Dream Query, what we've done in a few cases is you just copy and like paste that verbatim into your top level components, and for the fields that are available, you can start using, and you just kind of comment out the fields that aren't available yet and fetch them from somewhere else or put a to-do thing. And that provides you like a natural migration path, because you can then like create tickets for each one of those fields that's commented out, and split work up that way. So we've used it in quite a few projects, and it kind of helps to teach people what's available in a schema, GraphQL syntax, and kind of helps from the planning perspective as well.
Yeah, I love the term Dream Query. Like that's so like succinctly captures the approach that I also heard this like as a like on college campuses, where they have like a big quad or a big central area, and they don't pave it over until they've learned all the like desire paths where students will walk, and then you have like the the dream
path, yeah.
path, I guess. Yeah.
That makes so much sense. It's so like simple when you think about it. Like just write the query you want, but it avoids so many pitfalls that people usually get into, like starting by like, we often talk about this, but like starting by the database schema, or like even starting with the GraphQL schema. In this case, like you might produce something that you don't like as much as if you wrote the query in the first place, like focusing on the use case itself. I wonder if, I know in your post you talk about mocking as well. Is that something, like if a field is not available now, can a client kind of like mock it while it's being built or something like this?
Ooh, okay. Few thoughts there. So number one, maybe not exactly what you're asking, but I have to talk about it because I love it so much, is GraphQL Faker. So for people who don't know, GraphQL Faker is it's like a project that you can just spin up in a Docker container, and you get a GraphQL page, in Chrome, and you can just start adding some dummy schema. And it kind of has like faker.js built into it, so you can get lorem ipsum type data out of that scheme without having to implement the resolvers, and then you can write a query against it. So for people wanting to try out the Dream query in their like dev version of their app without implementing any resolvers, they can do that. That's kind of like a quick way to just like get a feel for it and test it out, see if the schema compiles, if it's even valid syntax or not. In terms of like, okay, you wanted to deploy to prod with a Dream query, I want to say like Apollo client might have some smarts to do that with like client-side resolvers or something like that. But yeah, I feel like it would be simpler to just kind of like add a to-do string or something. Yeah.
So you mentioned people will write their Dream query in a Google Doc, so you can kind of like have reviewers take a look at it. Maybe like, hey, this already exists under this other name, or this doesn't exist at all. So you have this small team of schema reviewers, or is that kind of like anyone on the teams?
Right. So I think I've heard this like from like a lot of companies now, but like other people, when we first started the GraphQL schema, it's this like really small schema, and you want to kind of control, you want to be the gatekeepers of what's being added to the schema, because it's kind of new to a lot of people and there's not a lot of what's what I'm looking for, like existing knowledge baked into the schema that people could just copy and paste from. So you kind of want to bootstrap that and be protective of what's being added. So it was me and like five other people, or 6 other people for the longest time, for like the first year and a half that we were doing it, and we would give shipments to all of the schema changes that came through. Mm-hmm. And we're trying to transition into a space where we'll just let anyone add stuff to the schema. We're in this like middle phase now where there's still like a protection on who can click ship it, but kind of anyone can sign up to be a schema reviewer. Nice. And go through like the learning module. We've spent a lot of time on documentation and teaching people how to do schema stuff. That's been like probably as big of an effort as like the actual technical efforts, I want to say.
Right.
Yeah.
How did you do that? Like the teaching, is that like great documentation, or like actively teaching, like workshops?
Mostly just documentation, like a VPress site.
Yeah.
So trying not to like rephrase or copy what the like GraphQL.org docs say, but putting it into like a Yelp context. So lots of examples with users and businesses, stuff like that. And then kind of, okay, how do you use our abstractions? What are some like schema do's and don'ts? We have a whole page on that. Mm-hmm. I'm trying to think of like, yeah, there's a lot of like stuff we've had to like figure out, like nullability, like what should be null, what should not be null. We're actually still trying to think through that one. So that's a discussion I'm like really interested in having, if anyone wants to have that. Server-driven UI is like another like big thing we're thinking about at the moment. So all of these, like, here's how we think this should be done, it's kind of like collected up in this documentation, and people can go and read that. Yeah.
You mentioned nullability in the schema. That's something we're very much trying to figure out, or find like a good set of like general guidelines on how to kind of think about that, and how just how it plays out in a schema. And it's not always clear. I think some things we kind of go back and forth on is like, is something non-nullable required? Like, is that like what does it mean for something to be non-nullable? Yeah. And I'm not really happy with the guidelines we found yet. Like, I think there's still some more to dig around. But I don't know. Maybe you can talk a little bit about like where you've landed on that, or like kind of what the challenges are. It sounds like you've got a similar system to us where we've got like a bunch of services that make up an aggregated response.
Right.
And getting the data from any of those services can fail for whatever reason.
Yeah. So the fact that it is this big, blob of like network call here, network call there, like any of those can fail, and so that's like really well encoded in a nullable field. So I think everyone like gets the intent and the like theory behind it. The real world implication, though, is that when you have the data response object, it contains lots of maybe types, which is okay if you're in JavaScript. You can use optional chaining maybe for mobile clients, where you're doing like type generation of the like response objects, and to like force unwrap all these things. And if you get something wrong, you could crash the app. Like it's very tricky. Like a developer usually wants to just check, okay, is this object that I got back from the server, like, is it valid? Can I just like pass this to my components and it knows how to deal with that? To have to kind of like go through every like leaf node on that object and check, is it null or not? That's something that we found people aren't so thrilled about.
Right.
So finding the right balance there. And then what do you do about like allowed nullability? So if a business type has a like claimed attribute, like has an owner claimed this business yet, that's like could legitimately be null. So it's very hard to give a make everything null or make everything not null kind of guidance. And so then you're having to operate with shades of gray and kind of teach what. I don't know. It's hard. But I like the idea that I've seen proposed in some blog posts, the idea of like having a client side having a directive in the schema, or I don't know, maybe it could be like a language proposal or something, that you could mark from a query what I'm okay with being null and what I'm okay with not being null, and that can kind of like bubble up, and so you'd get semantics that could be known to type generation. I think that'd be really cool. I'd love to see some tooling in that space.
Yeah, I think I've read that in an Artsy blog post. I think it's them. They have a directive that like kind of like annotates an area of the query that's like, I really need this. Right. Like if this one is null, I can't render the page at all. The rest is like kind of like more optional. Yeah, it's such a, it's hard. Sometimes I wish it was like kind of like protobuf and we just made everything nullable and went forward with that. But it's true, the distinction between I'm null and that's supposed to represent something from the business versus I'm null because you can't see that or like there's an error is kind of weird. I always like, I think a good guideline for nullable fields like the claim idea is a cool one. Is like your description should probably include what, like if the field is null, here's why. That helps a lot, but then it's kind of like it's not really machine readable, which sucks. So yeah, it's a hard one for us. What we decided on is we notice most things that can be null in the end are object types. Like it's rare we query a scalar and it's gonna be null because of an error, because usually we fetch kind of like the parent object. If that's succeeded, we get the scalar field. So that's kind of like our rule of thumb, is like scalars are usually non-nullable. Object types, really think twice if you want to make it not nullable.
Right.
The argument I've heard kind of is, okay, if you want to like migrate the source of the data to be somewhere else, like maybe you make a new service that's like a super quick, more efficient call to get the data or something. I don't know, but I think like thinking about how you want to deal with it in the UI if part of the response fails, and being like, okay, well, I need partial results so I can display just the header and let the body load in as a retry later or something like that. But then how often are people actually doing that rather than just like crashing the page and letting people to refresh? I don't know. It's a really tough problem.
Yeah. Speaking of kind of like loading data from different places, I know you've been working on this other thing, another blog post actually you've made about data loaders, and kind of a way you kind of generate them automatically based on your backend services. Can you talk a bit about that? That's super interesting.
Yeah. Okay, so like I said, we have kind of lots of different backend services. So that equates to like hundreds of endpoints. And we want to talk to those endpoints in the GraphQL server. So we started off doing like the dumb thing, just kind of like making a bunch of like network requests there, and then like, okay, we need data loaders, so you add some data loaders, and then those data loaders are each implemented slightly differently, like they're mostly copied and pasted, but because each endpoint is implemented slightly differently, like some of them, accept like multiple keys and return you multiple responses, some of them just kind of return you one thing at a time, in different, entirely wonderful different shapes. So there's a lot of like variation, but a finite variation in kind of how these endpoints can be implemented, but just enough variation to make it like infuriating to try and like read through all of the kind of human written data loaders, because that affects how you call it in the result. You need to know how it's implemented. So our endpoints are all typed with Swagger. So that was kind of like a good starting point that, okay, at least we have like some type information somewhere. Mm-hmm. So we already had this like baseline of being able to generate like client libraries in Python, and that's kind of how services talk to each other at Yelp, usually through these like auto-generated Python client libs. So we generated some Node client libs, which great. Now we have like flow types, use flow. And so then we have like an additional layer of code gen, which is to declare a YAML file describing all of the different endpoints. And it's like a minimal thing where all you need to do is define what the like lookup key is in that thing, and then you run the code gen, and it generates you data loaders that you can import and put onto the context object. And so that kind of like really normalizes how developers get data. And the leap here is that we don't want developers to have to think about data loaders. We don't want them to have to kind of think about this layer of abstraction, because our developers were already familiar with the endpoints, like they'd written those endpoints, and having a known way in which that endpoint turns into a data loader in an expected, predictable way. Now we have like hundreds of data loaders, I guess, in the server, and that's kind of what the project is about.
So let's say I want to add a user loader, and I work at Yelp. So in my mind, there's two things I want to know, like like which individual keys I want to load. So like for me, it'd be like I want to load from a user ID, and then I guess the other thing you'd provide is which endpoint is able to kind of like batch all of those together. Is that kind of like what the YAML file defines?
So the YAML file is like a mapping of the endpoint. So in Swagger, you get like a API name dot endpoint name. So you just kind of like map that into the YAML file, and it has options for, okay, maybe the response object is nested or something under this like prefix. So you can add that in the config file, so you can like remove that random like nesting that endpoint randomly provides. So inside of a data loader, you just get back like the object that you expect, basically. And then also worth mentioning that maybe someone, let's say we have like a get user v1 endpoint or something.
Right.
In the old world, there's nothing stopping someone from making like 5 different user data loaders that took different shapes of keys, which would mean you don't batch up stuff to those user endpoints anymore. So That's kind of like been another win for us there.
Does that mean all your backing services like expose a way to get something in a batch? Is that kind of like a convention you have, or?
Yeah, it's definitely a convention that some of them have. Not all of them have batch versions of the endpoint. Some of them, it's just like a get one thing at a time. So that's like another config option in the YAML file is this a batch endpoint? If so, what is the batch key and what do you want to map it to? So you might have user IDs as like the thing that the endpoint takes, but when you do, user.load, you want to pass user.load with user ID
right.
singular. So kind of you provide that mapping in the config file. And so then in the implementation, it will create like a fake, batch wrapper on top of
Makes
that.
sense. It's really interesting to me, for better or worse, that GraphQL kind of like imposes a shape on whatever it's in front of. Like, is it ever an issue where like there's this old service that you need to kind of like revive or add a batch endpoint because it's too slow to like do these individual kind of like calls, or were things already kind of designed in a way that where batching and kind of like async loading like that works out of the box?
Yeah, I think for the most part, I don't think we've had many use cases of where someone's noticed an endpoint being super slow in GraphQL uniquely, and they've had to go back and like change a bunch of stuff, because a lot of these endpoints have been like battle tested and have been really well used, on existing pages. So all of the like super high traffic stuff that needs to be batched was, already batched. So the years of experience we kind of built up with these endpoints have served us
Very
well.
cool.
We do have the use case at Twitch where we have some. So Twitch used to be like a one monolith, and we actually were able to kill it after transitioning to a bunch of services. But we do have some old services that still are not batched, and we have an adapter in the data loader layer that makes it look in the application as if it is, but it's not. All the requests just fire out in parallel. So that they're not like serially waiting for like one to the other. Like it's just, you get a lot more connections on the network, and sometimes that's an issue, but it's kind of a good adapter in the meantime. If a team's like, I need this feature, I'm working with a service that's not easy to batch or for whatever reason, and it provides kind of a bridge for us to get the functionality out, while still making it kind of like papering over the fact that it's not actually batched.
Yeah, that makes sense. I guess like in the end, like if your database, like at the end of all these calls, if your database can handle it, you're not too bad. If it gets to the point where it can't, is where that gets hard. Yeah.
We're only serving read requests right now, so in theory, that's like very very scalable. Once we do write operations, we'll have to think maybe a bit more about that.
So is there no mutations in your schema so far?
Not yet, but if anyone wants to come help us work on that, then yeah, yelp.com/careers.
Any link to that? Yeah. How big is your GraphQL team? Is it kind of like, so like Tony and I work kind of like on specific kind of API at teams. Is kind of like the same for you? I think you mentioned it was like kind of internal and not the external ones.
Yeah, I don't have any good answers for you on the external GraphQL stuff, but on the internal, it's there's like a group of people behind it.
So I think we were chatting before we started the stream. You're using Node, right? So the GraphQL kind of like gateway is written in Node, and are you using kind of like a specific GraphQL library, or is that like all homemade?
Sorry, I fizzled out. Can you repeat that? Sorry.
Your gateway is built using Node.js, is that right? The GraphQL part?
Yes. We're a Python shop, but we went with Node for this because that's kind of at the time where a lot of tooling and stuff had been built that we wanted to use. So Node.
Makes sense. Are you using something specific like Apollo Server or Nexus, or is it kind of like homemade?
It's not definitely not homemade. Apollo stack for
Nice.
now.
It's we're not in the Node ecosystem on the server side at Twitch, and I always feel a little bit of like tooling envy because that's where so much of the tooling seems to exist, at least at the surface level. Like, so I'm very jealous of all the nice tools that the Node ecosystem provides for GraphQL. It's kind of like the home ground.
Yeah, we're lucky because we started off with this GraphQL monolith. So we haven't yet talked about federation or anything like that, but that's not something we do. So we still have everything written in the one GraphQL server,
Mm-hmm.
and small things like being able to split up where resolvers live is pretty neat, and a lot of tooling that allows us to kind of enforce separation of how data can be threaded through things to make sure that you're only passing in like IDs and not kind of like arbitrary, sets of stuff in as the parent object. So, the tooling is pretty nice. And then there's like tooling that we're using, which is, I guess, not tied to any specific like server implementation, but the world of tooling, like GraphQL Inspector and stuff like that. Really, really enjoying that.
Nice. You mentioned kind of like enforcing boundaries. Is that, I think, what you just said, where you make sure like things are passed by ID, so you can eventually kind of like split it up, but it's still a monolith. Are you using any like specific tools like linters to do that?
So we have we use pre-commits, and we have like a bunch of scripts that run at commit time to make sure that people aren't adding bad stuff, I guess. I'm trying to think of like some good examples if I can share. It's possible that one day we might split up the schema. Well, we're not exactly sure how we do that, but we use Flow, so having type safety is a huge win. So making sure that we know what's going to be passed as the parent object is huge, because we can say, okay, if we know that everything that creates a user type or a business type only creates it by passing the ID as the parent object, then that kind of gives us confidence that we could have a like user GraphQL service or something which just takes in ID, and there's not too much like minimal refactoring we would have to do in the gateway side of things. So there's a lot of like speculative stuff we're doing like that. Things like generators, sure that when people add new types, the style in which we write resolvers, kind of like if it's an ES6 class versus just like a object literal, we have kind of conventions there. So yeah, basically we have like lots of scripts to enforce the conventions that we set up.
That's very cool, because like I feel like the federation seems amazing when you need it, but it seems like a lot of people will say like, I need federation because I really need to separate my concerns, but they forget like that's a thing. Even if you have one code base, you can still like design your code base in a way that separates these concerns in the first place. So I'm really curious, like, have you, because we have a huge schema as well, and kind of that separation of concerns at the schema level hasn't been a pain at all. Separation concern in code in general is a hard thing, especially with an old code base, but at the schema level, it hasn't been so much of a pain. I'm curious, have you been feeling these pains? Like, do you feel like you need to separate your schema across different services?
We've not hit that point yet. So there are signals that I kind of think we're looking out for to say, hey, we need to split this up. So things like how often can you push the service? How long does the test suite take to run? The volume of errors, and is it too noisy? So kind of the operational stuff, I think, is more challenging in terms of having a monolith. The separation of concerns at the code level, in the schema, so we have like a SDL first approach. So in the schema, we're pretty organized in terms of how we split up stuff. So a folder per type, and then we make good use of kind of extending different types, and everything has its home. And then we have like ownership on type. So if a type exists in the schema, we know who owns it. So I think we're in a pretty good place in terms of the schema, pure schema side of things. On the resolvers, we try and mirror that structure as well. So that kind of provides us like just a convention to help manage things. Yeah.
Yeah. So connected and related.
Yeah. One of the things that kind of distinguishes us from a public schema is that we have an allow list. We know what queries are going to be sent to us, and before a query can be sent, it has to be added to this allow list. And then, again, queries are associated with owners, the team who submitted that query. And so when stuff goes wrong, when a resolver fails, unless it's a like async error or some infra error, if it's just like a normal resolver error, we can tie that back to the query that produced that error. So we can alert based on, hey, this query failed. And even though, this like random feature team doesn't really care about this type, you're still using it. And, I guess you're a heavy user of it. So, at least you can kind of help triage and wake the people up who do know about it. So that's kind of also been quite helpful.
Yeah. It's interesting about like how ownership helps in operation in terms of like, this thing's broken, who do I poke to get it fixed? So I've had this problem, and I think Mark with a K, you've had this problem as well. But when something happens with an underlying service or data store, and we start getting errors in the API layer, is that something? Have you experienced like you get paged for it, or like someone's like, "Hey, GraphQL's not working," but really it's like, "Oh, the user's service data store is missing something." I don't know. Do you use this ownership to drive like that kind of triaging, or do you find yourself getting paged a lot for things that are not really in your area of responsibility?
Yeah. Okay. Lots to
unpack.
Yeah. Okay. So we have pretty good. So we have like custom error classes, and okay. So if an error is produced by a upstream service, like a service that we're calling, then instead of just getting like a generic, hey, something went wrong, we worked very hard because we were getting paged so much, we worked very hard to include as much information as possible in the custom error object that gets displayed in like Splunk lines and log lines. So when you see a GraphQL error, if it did come from like the user service or whatever, you would see resolver error, this is an upstream service error because the user service returned 500. And then you can dig in more, and if you go into Splunk, and you can see the like response HTML, whatever, from the upstream service. So having that observability is pretty nice, and kind of our team who will get woken up. We know how to read that, and that really helps.
That makes a lot of sense. That seems super useful. Do you so now that you tag kind of your errors like this, you could determine if there's a problem with the GraphQL platform itself, like whatever middleware maybe your team is taking care of, or it's an underlying service. Do you build monitors based on that? Like, can you exclude kind of like GraphQL platform errors and only page the underlying service team this way? Or would you still, like, if GraphQL returns a 500 because of an underlying service, are you still kind of involved in an incident, for example?
Yeah. So we have a few services like this where our team owns the GraphQL service, but we kind of don't really own any of the types in the service. We don't own any of the like application runtime code. Well, we own the infra, like the Express server, the infra layer. And so if processes are restarting, or the Docker containers are falling over, or if running out of memory, or like infra level errors, we will get paged for because we own that stuff. If there are GraphQL runtime errors, if there's resolver errors, we try and page the team who submitted the query that's failing, and we won't get alerted for it because it's not our query, and we hope that the team can debug themselves. Some of the time we'll get looped in, some of the time we won't. A lot of the time we won't. So being able to kind of separate out different classes of errors, that definitely helps us sleep a bit better.
Yeah, that's great. Definitely taking note of that. It's I think it's good to highlight that this is one thing that is a little harder when opting for GraphQL compared to REST, just because you don't get the separation out of the box.
Yeah. So Apollo server has the error code field, right? And you can create custom errors, so you can give everything an error code. And any error that comes at the GraphQL layer, you can add like a plugin or a hook. There's like multiple ways of kind of listening for GraphQL layer errors, and then you can emit a log line for that. And you can also emit log lines outside of GraphQL, at the like server middleware layer. But every log line is tagged with a error code, and sometimes it comes from Apollo, sometimes it comes from we're out of memory. But yeah, kind of classifying based on that error code. That's really helpful.
Speaking of observability, maybe we're going to go deeper into that. This is something I find personally very challenging with GraphQL. Is like actually, like, besides errors, like finding out that something is misbehaving, especially in a context like yours where many different moving parts may be misbehaving. What kind of like instrumentation do you have in place? Is that, I assume you already had instrumentations for anything that's service communication, but is there anything on top, like GraphQL specific?
So all of our services are deployed on Pasta, which is kind of the platform as a service architecture that Yelp runs on, and lots of blog posts about that. But it all runs on Docker, and so you get kind of some Docker stats that are automatically pulled into a graph for you. So things like memory usage and CPU usage and CPU throttling. That's kind of a big one. It's like an early indicator of, hey, you should probably give it some more memory or something because of garbage collection or whatever. So having those three things, that's probably the biggest thing. And then there's kind of like custom things that we want to keep an eye on, such as how often our use like the cluster module. So how often are like sub-processes restarting? Like why are they restarting? So like interesting events, I guess, that we care about, we will explicitly log for. We also do distributed tracing of requests. So you can like load yelp.com/whatever and see like a tree view of every hop, every service that was hit in that request. And we don't do like per resolver tracing because it would just like balloon in complexity, but you can see the resultant network requests to the backend services that are made. What's really helpful is we use GraphQL Playground in dev, which does give you the per resolver, breakdown and how long each thing took. So that's pretty helpful.
And it does that because you're probably kind of like responding with some extension for the performance. So you do measure it in some way, or is that kind of like out of the box with the server you're using?
In production right now, we don't kind of return anything in the extensions fields. The client just gets like the minimal response it needs. In dev, you do get that extensions response. That's just kind of like, I think that's just kind of like you get that free with Apollo. Nice. So being able to kind of drill down and see what's happening in a dev or stage environments is really helpful.
Yeah, definitely. So in production, you're mainly focusing on the backing services. You don't have necessarily like you can't see the per field timings for a certain field. Is that right?
Not yet, but I think we're going to be working on that.
Yeah, nice.
Do you use like a distributed tracing framework, or is that just via like logging a unique ID across every system, like to like logs that you read with like Splunk or something like that?
Zipkin is
Zipkin.
What we use, yeah.
Yeah, we tried to do per field tracing, and it's kind of weird because since we're so IO network heavy, most of the time you're either waiting on the network or you're instantly returning the value from memory. So sometimes it could be with like a data loader. You could wait one time on the network and then instantly pull it out of the cache the next time. So it was a lot of information. It was hard to find a good use for it because you kind of want to know like what's breaking and what's slow. I think I really like the approach of just logging the network request from the service. Like I think that's a good middle ground where you still get like a high value information, but without having so much baggage in terms of like kind of useless data.
Yeah, I think one thing I'd like more kind of insight on is to the like crunch time, the overhead of GraphQL and how much time that's adding. But I just like kind of most time is spent waiting network stuff, and you can already see that in the distributed tracing breakdown. And yeah, if this like slow endpoint is slow, then you can go in and fix that, and then the Gray will be super fast again. That's the theory, at least.
Yeah, no, that makes sense. I think that's totally right. I think most of the time it's like spent somewhere on the network, like either to a database directly for us or querying from a service. And it's true that like field resolver timings, if I look at any logs and even like people I see who have this, just like observability of fields and use Dataloader is so often kind of useless because, as you said, Tony, like one field might be returning in like 1 millisecond from memory, but that's because one other field like had all the costs. It loaded like literally everything because that's how kind of like the async process worked. And then you request again, and it might be another field this time, depending on the ordering. So it gets really hard to see what actually is slow. So I agree, like just seeing a query and what got enqueued or what got loaded on the side seems almost better at this point.
Yeah.
Again, I think because we have the luxury of knowing the shape of all requests that are going to come, developers will have tested queries on dev to make sure that it's not like horribly slow, and kind of they can dig in more there. But I don't know what you would do if you're in a public setting where you can get any type of request. I think like budgets, and I do know on the public GraphQL side of things, we kind of have like depth limits and yeah, stuff like that. So
that makes sense. Yeah, the whole instrumenting data loaders is hard, but as you said, like since coming back to like the dream query thing, since you know the queries ahead of time, even kind of like when they're designed, it sounds like, do you use anything like kind of like the allow list thing where no client can start like requesting arbitrary queries, or is it kind of an in-between approach? Like, is it kind of like locked down to only queries that pass through your process?
It's entirely locked down. Okay. So you cannot you cannot curl it with an arbitrary query. Once your team feels comfortable, we don't have like a process for like when you can submit the query, but like once you get to ship it on your client branch, you can run a custom command tooling that we have to submit the query to the allow list, and then it will be publicly queryable. So we crunch like a char of it and store it in a database somewhere. And it's really just kind of a protection to make sure that we don't have malicious third-party people, trying all sorts of interesting shapes of data, and making sure that people are conscious about, okay, I really want to query this shape of data, like I thought about it. And like there's a paper trail.
That makes a lot of sense. Yeah, I'm jealous of this. Knowing queries ahead of time.
Yeah. It seems like a nice property. Do you use like a persistent query protocol, or?
It's kind of hacked into the server right now, homegrown.
Yeah.
Makes sense. But it's because we've done that, we have been able to build a lot of tooling on top of that. So when you send pull requests, we can sort of show you all sorts of insights. Like if you're trying to delete a field, then we can say, hey, you're trying to delete a field, change. But we can also say it's breaking change, but don't worry about it because no one has been querying this field.
Nice.
Over the last 2 weeks, or it's a breaking change. Really, you should not delete this because these 5 queries have been hitting it in the last 2 weeks, and this is like a really super popular query that uses this field. It's owned by these people. If you really want to delete it, go talk to them. That kind of thing.
I love this kind of tooling.
Yeah.
It's great. Is that powered by? Part of it is GraphQL Inspector, I guess, for the breaking change, but then you tied in your own usage queries.
Yeah, exactly.
Nice. Just because I'm curious, are you using GitHub Actions to do that, or like kind of like your own GitHub app kind of thing?
That side of things is all homegrown for now.
Okay.
I think we're undergoing some changes there. But for now, it's all homegrown.
Sweet.
Yeah. I really like because I know GraphQL Inspector does allow you to just like integrate directly with GitHub stuff, which looks really nice, and comments kind of per field, and I guess GraphQL Doctor does like a sort of thing as well, which looks really interesting.
Yeah. GraphQL Doctor, I think is pretty much the same thing. Our usage data is interesting to get as well. As been we have so many different queries that we can't, like, the cool thing about you know exactly like which queries have been hitting. We know that as well, but we can't show it all to you. But we have kind of these sweet chat ups that people can use in Slack to know how many times the field have been used and everything.
And another interesting thing is, like, usually when you want to see how often has user.firstname been used, you can just kind of see, oh, it's been used like 20,000 times, or I'm just making a number here, but you can see like how many times the result has been hit. But what we can also do is we can show you how many queries that have been used in the last 2 weeks that it appears in. And that's kind of like a really interesting kind of metric to see like how many teams use this field rather than how many, queries use this field. Sorry, yeah, how many like network requests have used this field, I guess.
Right. I'm curious because this is something I see often when, let's say somebody builds a new client that will use GraphQL, do you kind of like force them to identify themselves in some way, like a client ID or something, so that people can you track pretty accurately like a query to a client or like a repo or like where that query is coming from?
Right now, the short answer is no, because we have only had the use case of our web app talk to GraphQL, but now we're kind of getting into more interesting spaces where like the mobile web app is going to be talking to GraphQL or is talking to GraphQL, and we're also exploring, or we are using GraphQL on mobile apps, which is like very exciting for us. We are going to start identifying kind of getting more resolution on user agents.
Yep.
But that's like that's not enforced, I guess. I think it will be on the mobile endpoints. But I guess also from like the web app side of things, it all looks like Yelp.com. When a user is in their browser, they don't know what like service or package that page got served from.
Right.
So yeah, the short answer is no. The long answer is also no.
TBD. Yeah.
Makes sense. All right. We're almost at the top of the hour. Mark, thank you so much for coming on. We've learned a ton. I'm amazed by the internal tooling you've got. That's really amazing and inspiring. Is there anything you wanted to plug? We've got the careers link in the chat and a few blog posts. Anything else?
Yeah, the careers thing, the blog posts. Yeah. Hi to my team as well. Web core, client data working group. Yeah.
Shout out.
All right.
Shout
out.
Tony, do we have a guest for next week?
Yes, we do. We have I know the Twitter name the best. Sashi.
Oh yeah.
She changes her name all the time on Twitter, usually to match the season. And she works at Twitter, and she's done a bunch of good work on proposing techniques to handle errors in GraphQL. So we'll be talking with her next week, and I'm super interested into digging into error design. Once I heard her proposal, I was like, wow, I wish I could time travel and go back and rewrite my entire API to use this. I think it's kind of like a union approach and like result types and everything. Yeah, it's amazing. I'm excited as well. I'm really interested to talk to her and figure out how this worked out in practice, and I don't know, any other tidbits of wisdom that she can drop. I'll be very much appreciative. So very much looking forward to that. And Mark, thank you so much for taking the time to chat. I'm really impressed with like Yelp's internal tooling. So pretty jealous of some of these things, and highly recommend reading the blog post Mark's mentioned. We take the same kind of approach as the Dream Query, although we don't have as cool a name as it. I really like that terminology. I'm gonna steal that one.
Yeah, no, thanks for having me on.
Thank you so much, Mark. For a few of our shout outs, we now have an official podcast, so whatever Apple or Spotify or whatever, you can find it. It's GraphQLfm. And I'll post the YouTube channel where this video will be on after. We're just missing one follower to hit 100, so we can have an not ugly URL like I just posted. So
maybe I'll do it right now.
All right. Thank you so much again. Thanks, Mark, again for coming on.
Thanks.
Thank you, Mark.